find the reading of voltmeter if resistance of lamp or decreases. Why decreases? I can give several reasons. Because as I switch on the circuit, current will flow. Due to flow of current, heat will be generated. Due to heat generated, the resistance can decrease due to some parameters. So as the resistance decreases, what will be the reading of voltmeter? That's what he is asking. So sorry. This is the thing. If R decreases, if the resistance, there's another problem. I'll come to that. Find the reading of voltmeter if resistance R. This R is here. So there's a voltmeter. Sir, is it ideal? Let it be ideal voltmeter. Then how the first see, these are not conceptual question. I don't know students what happened. They just want to see and answer it. You begin with the basics. So let this be IB. Current will flow like this. So and this will be VB. Applying KCL. This will be IE. This IB. This IC. This is IC. This is VC. Okay, now let's begin with a set of equations. Plus VBB minus IBR minus VB equal to 0. So we are IB is equal to VBB minus VBE by R. There's a one equation. Next, after this, let me write one loop equation for this. VCC minus, this lamp will have some resistance. RL, I'll write it. ICRL minus VCE equal to 0. I'm just bringing some, we'll take some different set of numericals in transistor circuit. I'll bring Zener diode, I'll bring LED, I'll bring photodiode, I'll bring solar cell, I'll bring a lamp. What conditions will arise? So then this will become IC is equal to VCC minus VCE by RL. Now, as R decreases, what is the thing? R decreases. If R decreases, what should happen to IB? We have here data. If R decreases, IB will increase. And we have some relationship IC is equal to beta IB. If IB increases, IC will increase. If IC increases, tell me what is the reading of voltmeter? The reading of voltmeter is V equal to IC into resistance of lamp. RL, resistance of the lamp, let it be constant. I'm not going to disturb it. So as IC increases, RL into IC, I'll write it. No, if this IC increases, then they should also increase. There's a method of tracing out things. Huh? No guesswork. I'm making things clear. I can bring one resistor here. I can change this resistor. What will be that? Any resistance if I change here or here or here? What will happen to parameters at other part? Right? All set of equations signed. Verify that how quantities are related to each other. Here I can increase the R, I can decrease the R. Here R decreases, this drop will increase. The drop across this lamp will increase in the transistor C amplifier circuit.
Sir,
Ah,
V will be RL into IC plus VCB, no, sir.
which one?
This here only, sir, that red V. V equal to RL into IC plus VCB for that loop.
Oh, you mean to say VCB also will come into picture, no?
Yes, sir.
Also, sir, in the first equation that you wrote, IB equal to VBB minus VBE by R. When R decreases, we don't know what will happen to VBE, so we can't comment on IB also.
No, VB is a fixed value at 0.5.
Okay, sir.
The bias voltage. Okay, I'll do one thing. So some of you are. I'll set it. Some this VC, no. So this will do one thing. ICRC minus VCB, no. Okay, no problem with this. This collector base will be reverse biased, no. There'll be a drop. This one. VB is a fixed here.
Yes, sir.
So still it will increase only. Yeah.
It will be constant value, no, sir.
This will be constant.
Whole value will be constant, sir. From
This
the above
will
equation, RL into IC equal to VCC minus VCE, no, sir.
RL into IC. That one. See, there'll be effect of VC. No, if IC changes, if this drop changes, then what happen? VCC minus ICRC. I'll bring back this. Huh?
Sir,
No,
VC will be constant or varying, sir.
There's a constant. There's a cell should be a constant.
Then everything will be constant. Whole V, capital V
Okay,
will be.
let me speak. So VCC ICRC minus VCE. Okay, that one. As IC changes, VC also will change. It's not like something and all.
Sure, when we'll take RL into IC, it will get VCB minus VCE, sir. That will be minus of VB, so it will be constant, sir.
No, not like that. Not like that. If I decrease this, IB decreases, IC decreases. If IC decreases, then VC what will happen? IC equal to VC equal to VC will increase. I'll put everything. What is there in that one? Huh? If IC increases, then VC what happen will decrease. We know VCE is equal to VCB plus VB. VB is almost a constant. Huh? If VC decreases, VB is a constant.
So VCB also decreases, no, sir.
Let me. I too. I think I. Let me take all the equations at one place. Then it'll be easy for me. After this, VC equal to VCC minus ICRC. Okay, this is the thing. Now we'll check in this what will happen as IC increases. This has to decrease if VC decreases. Okay, now we'll have equation VC equal to VCB plus VB. Anything here?
VCE decreases, so VCB decreases.
So finally, we'll get a constant. So both will be linearly positive and negative.
Not. What is the effect of VB forward bias voltage? No, usually we say 0.5. Effect of this VCB is what we are got stuck. No. I can write one loop equation like this also, but this is the old meter, no? plus VCC minus V IBRB minus VB equals 0. Oh, let me check it.
Sir, even in question he asked the reading of voltmeter, sir. He didn't ask the, I mean, it will decrease or increase, sir. So because it is constant, sir.
Wait. Don't be hurry. Hai na? B plus IBRB minus VBB equals 0. Okay, no. This is R. VB should VC decreases. VCB. Okay, we'll write it. You know. VCB also decreases. VCB decreases, then this will be positive or negative. This is the it will be negative value, no? Collector base reverse biased. Because if it is an active region, collector base junction will be negative value. Huh?
C will be at positive terminal, no, sir, with respect to B.
No.
We can get the answer in one loop only. We'll write a loop through VCC, through ideal voltmeter, VBE. That's it, sir. That if we write that loop, then we can get the answer easily.
Yes, sir. It will.
No, the
One
one
step
loop,
we'll get.
no. VCC minus V minus VB equal to 0.
VCC and VBE are constant, so V is also constant.
No. This is forward bias, no? Something we can't, because as I'm changing R, there'll be some impact on this one, huh? The forward bias.
In question itself, he gave it as constant, no, sir.
Yeah, that one. If we say 0.5, then we can't say anything. Okay, then I think yes. If I remove this, check in this one, huh? Because most of the question they don't give VB. We'll conclude for this one. Huh? VCC
Then
minus
we
V
have
minus
equation.
VB equals 0. Okay, what will happen to VB? So I think definitely if I decrease R,
Need some other conditions.
what is the effect of VB? You know,
Then we should solve the entire thing, sir. Whatever you wrote, we can't simply
We'll get
take
the
from
same
these
thing, sir.
equations.
One more condition is required to get a conclusion.
More
Sir.
condition we need.
this VCB will be negative, no, the value. Oh, okay. Only thing, collector will be more positive than the base. That's the only thing. If I connect one voltmeter, they should be positive. This will be positive means the equation will be what I wrote. Okay, let me write equation. KVL. Guessing will be problem. The VCB will be like this. Minus ICRL minus VCB plus V equal to 0. Yeah. Yeah, same thing. The reading of voltmeter is asking, no? So we need the idea of VCB. What will happen to VCB? If nothing is said about VB, you know, even if this is a variable, if RB decrease, if R decreases, IB increases. IB increases according to the graph. Okay, no. Well, I have to.
Sir,
Just wait. Let me. This will be IB versus VB because it's a forward bias. No? If IB increases, then VB also will increase. We'll put it this one. IB increases if VB also will increase. If VB increases, VCB is decreasing, no? VCB decreasing and IC is increasing.
Sir will subtract the original two equations that you wrote. We'll get VCB from there.
That's what VC minus VB I'm writing, no?
Yes, sir. We have to solve, so we can't comment like this.
Okay, now just let me conclude. So VC is what? Decreasing, no? So there's a decreasing. VC will be large, no? So the difference will be, this will be increasing, this will be, VCB decreases, VCB decreases. Oh, okay, VCB decreases here. IC will be increasing. What is the product of these two is what now we have to check it. Means this one, this will be increasing, this will be decreasing. Reverse bias will be very small, no? This will be. Let me just check the, in the collector base, no, usually it's a reverse bias very small changes.
Will decrease, no, sir. If VB increases, that particular V will decrease. To
VB.
simplify, we can substitute the value of ICRL
No, we
value
need,
that time will get.
no, only just theoretically we are analyzing, no? Just I'll yeah. It has to obey this particular graph also, conditions.
Sir, the second equation is not satisfying the graph, sir. First graph.
This one, huh?
IB equal to VBB minus VBE by R. That
No,
equation.
there's a forward bias, sir. Don't look at mathematics. There's a diode. It should obey this one. Finish over. Based on this is what you should adjust the mathematical conditions. That's what I wrote. IB and VB increasing. Huh? Okay, what we have. If it is an active region, we can say something here, no? VC increases. The effect of this will be negligible, huh? Usually. The effect of this reverse bias, no, will be very negligible on this particular thing. Because according to the graph, as you increase IB, IC increases. Am I right? As we increase this IB, common emitter configuration, as we increase IB, then IC was increasing. For a given value of VC, as we increase IB, IC increases. Okay, then I'd like to conclude something. This will be negligible, we'll write it. Provided what I discuss is active region, strictly condition. Saturation cutoff, we should not discuss this concept. No, this will be more dangerous problem. So it's available, I think, in some of the textbooks. Any doubt if you have, you can clarify it.
Sir, when IB increases, how are you telling VB increases, sir? I mean, from mathematics, it is wrong, no, sir.
My dear, this is what the diode should obey, no? Finish over.
Then that equation should be wrong, no, sir.
Not, I don't know, like, see, this is the only the KVL is what you are writing it here, no? This will be, if VB increases, IB must increase. How IB is I'm varying by R. There's a forward bias, no? The diode, it's a non-linear device. You're trying to adjust things from here. No, not possible.
Sure.
When you vary R, VB and IB, both will be affected. It's not like R decreases, then IB increases, then it will
Yes,
show
sir.
impact. When you vary R, both will have impact. Both there'll be changes. Huh? And this graph is very important. Without this, I should not conclude anything here. Huh? And what all we
Sure.
discuss is active region. Yeah.
Sure, here ICRL equal to VCC minus VCE, no, sir.
ICRC is equal to
VC.
VCC minus VC. Yeah.
Once can you substitute in the last equation, sir? Last equation. The
No,
final equation where you conclude.
this is RL. Okay, I wrote RL. Huh?
Both are same only, no, sir. RCRL.
No, RCRL. I'll change symbol. Huh? Then it'll be easy for. No, you see that we have to just the quantities increasing and decreasing. No, so nothing but you're asking us to write the equation like this or like this. We have to just correlate the terms.
Question is asking the exact value.
No, what will happen? No,
Find the reading. Okay.
reading in the sense increases or decreases, not exact value. Exact value unless we don't have values, we can't find out. No,
In
what
terms of variable, I meant.
what will be the okay? You are what will happen to the reading of voltmeter? What will
And because one is increasing, one is decreasing, we have to solve and substitute.
what will happen to reading? If they give value, we can easily verify it. Without values, I think only we can say increases or what will happen to increases or decreases is asking. If resistance are decreases. Or check whether the reading of voltmeter increases, decreases, or remains constant.
Sure, ICRC equal to once that can you substitute and do, sir.
Whatever you do it.
Then we'll get V equal to VCC minus VBE, no, sir.
Okay, the end equation.
Yes, sir.
V equal to ICRC. Okay, let me do that. No problem.
We'll get constant only. So
Constant only. No, will not happen.
From the
Some
graph,
changes will be
all
there.
KCL equations only we are writing, no, sir.
sure, once right, sir, it's okay.
You substitute, sir.
Okay, what is the equation? You tell me, I'll write it.
V equal to
V equal to VCC
VCC
minus.
minus VBE from the bigger loop, sir, which Kushal told initially that one. From here,
Okay, this one.
from the graph, VBE is increasing, no, sir, as IB will be increasing. So we should decrease, sir, because VCC is constant.
This will be a constant. Okay, that I don't know. Yeah.
So since VB is increasing, we should decrease, no, sir.
Not sliding up. Yeah. Okay. You are telling from there. This is constant. This will be increasing. So you are saying this is decreasing. Okay,
Yes, sir.
this will be much easier, no? Yeah. Okay. Fine. This is very
Why
simple.
VB increasing, sir?
Forward bias. Simple idea. There's a diode. No. Don't forget about transistor. Okay. Oh.
IB is increasing. Who said IB is increasing? That first equation, we cannot conclude that IB is increasing now, sir, because IB is dependent on VB.
Say across a diode, if this increases, this should increase. Forget about this one. There's a
Sir,
diode
IB
condition.
is increasing or decreasing, how can we conclude?
There's a potential drop, no?
VBB minus VB is also dependent.
No, not like
VB
that. No.
is
Across a diode, see one very simple. 2 ohm. Okay, 10 volt, I'll write it. Let's talk about the ideal case. I is equal to 10 by 2. So let me take 5 ohm, 2 ampere. If I make this 2 ohm, then how much of current will be? I dash will be 10 by 2. So what happened to current here? For 5 ampere. So what we are doing here now, the forward bias across this is what we are increasing. No, you have to think in this way. The forward bias across this has increased because it has to obey this curve. Without this curve, I think will be nowhere in the picture. I should not say this is wrong because there's a diode. The base emitter junction is the one diode. Let's not bother that collector
Here we
base
are
or the
taking
transistor.
ideal case now, sir.
Let it be same thing. Same thing.
There it's not ideal now, sir.
No, even if put some 0.5 or something, no, even then also the
Sir,
situation.
that VB is constant or varying, sir? VB should vary now, sir.
No, even this because as you vary this R, the bias across this will vary. That's what happens here. Because if current varies, then the bias across that also should vary. So you mean to say, sir, like you took ideal. Okay, let me bring VB now. In that case, if current increase, the forward bias also should increase. This is the condition. It has to obey this curve. Huh? Without this curve, we should not think. That's what I feel.
Sir, I agree with the curve, sir. I'm saying how you're concluding that I is increasing.
By varying resistance, the resistance of circuit.
That time VB also will change now, sir. We are getting I in terms of VB and R.
You are thinking mathematically, but practically what will happen, the drop and the current through the diode is determined by this curve. Okay, that one, if current increases, current through the diode increases, forward bias must increase. There's a rule, finish over.
But that curve doesn't have R in the picture, sir. We are taking in reference to R. Like what will happen if R decreases?
No, this
What's
R
this
is what,
relation between
see,
I and V, sir?
this R is, see, like this R, what will happen will determine the flow of current. And the current through the diode, what I can control by varying this R. This is condition is what we have brought it.
Sir, you're saying that VF is increasing because IF is increasing.
That's that is a
Why
rule,
IF
no?
is increasing, sir?
Forward bias, because R is varying. Resistance of circuit, no, because if I vary this, current will change or not.
Current will change, sir, but how you are saying increase, sir?
No, there's a relationship here. Huh? So across a diode, what is this IF, VF? Across the diode, that one. Even if I write 0.5 volt, okay, it will be the forward bias across that will increase.
Forward bias will decrease.
If current increases, then forward bias will increase, no?
Okay, sir.
There's a rule which we have to accept here. Huh? Otherwise, there's nothing to that one. Huh? Okay, then we have two different things are there, no? Okay, let me. V decreasing, this is very simple. Huh? From this particular graph, we can say this one. If I write all the things, if it is an active region, change in collector base voltage, effect of this will be, so this conclusion is correct. Huh? There's no doubt with this. I'm how to say about VCB. If it is an active region, there'll be impact on the reverse bias also. How that reverse bias So the reverse bias is not only governed by IC and IB. Huh? I'll do one thing, that this we can't conclude using this. I'll write it. Huh? No conclusion from this data. Only this data is what helping us. Huh?
Sir, 11:30 కింద.
11:40. Yeah. Okay. Answer. I'll say put decreases. Huh? But all of you have to accept this. Huh? This is very important. Okay. We'll take the next one. Huh? So this data, please do remember, across the diode, this is a very, very important condition. Huh? Okay, let's take the next one more question.